Welcome, my name is Dr. DrWedding, and this is DrWedding DC17. The current divider rule. In this video, you will learn what the current divider rule is and how to use it to find the currents through the branches of a parallel circuit. The current divider rule is not a law like Ohm's law, Kirchhoff's voltage law, and Kirchhoff's current law. A law will always work and will work for every circuit. A rule will work in certain types of circuits. The current divider rule will only calculate the currents through the branches in a parallel circuit or the currents through the resistors in a parallel section of a larger and more complex circuit. It will not work with resistors in a series circuit or resistors in a series parallel circuit. The current divider rule equation is shown below. The current through a resistor in a parallel circuit is equal to a fraction of the total current, where the fraction is the total resistance over the resistor value. Just like the voltage divider rule that was covered in a previous video, the current divider rule equation is just Ohm's law in disguise. If you do not know what the voltage divider rule is, you should go back and watch DrWedding DC09. Here is an explanation of why this is Ohm's law and why it only works for a parallel circuit. Start with the current divider rule. You can combine the total resistance and the total current to get the total voltage. By multiplying both sides by R and rearranging the equation, you get V total equals the current through the resistor times the resistor. This generates a specific case of Ohm's law. The total voltage is only across a single resistor when the resistor is in parallel with the power supply. So, this equation will only work with parallel circuits. You may be asking yourself, why would I need to know a specific version of Ohm's law if the generic form of Ohm's law always works? Both the voltage divider rule and the current divider rule help you understand what is going on in a circuit. In both equations, the resistors create a fraction that is used to determine how much voltage or current a resistor gets. In a series circuit, large resistors take the most voltage. In a parallel circuit, small resistors take the most current. Furthermore, these two equations can help in more complex circuits. However, at this point, it is difficult to demonstrate how these two equations are used because we have not covered series parallel circuits, Thevenin voltage, and Norton currents. The best way to learn how to use this equation is through an example. Example 1. In the circuit above, find the current through each of the resistors using the current divider rule. As always, start by generating a table for the circuit and fill in the known information. In a parallel circuit, the voltage is the same across all of the resistors. To use the current divider rule, you need the total resistance. The total resistance can be calculated using the multi-resistor equation. If you are unfamiliar with the multi-resistor equation, you can learn how to use it in my previous video. DrWedding DC16. To use the current divider rule, you also need the total current. Using Ohm's law, the total voltage, and the total resistance, you can calculate the total current. Finally, you can use the current divider rule 3 times in a row to get the currents through each of the resistors. You can also see that the sum of these 3 currents is equal to the total current. Here is another example. Example 2. In the circuit above, find the current through each of the resistors using the current divider rule. At this point, you may wish to pause the video and try to solve the circuit on your own. When you are finished, you can restart the video to see the solution. As always, start by generating a table for the circuit and fill in the known information. In a parallel circuit, the voltage is the same across all of the resistors. To use the current divider rule, you need the total resistance. The total resistance can be calculated using the multi-resistor equation. To use the current divider rule, you also need the total current. Using Ohm's law, the total voltage, and the total resistance, you can calculate the total current. Finally, you can use the current divider rule 4 times in a row to get the currents through each of the resistors. And as it should be, the sum of the branch currents is equal to the total current. When the voltage divider rule and the current divider rule are presented using simple circuits, they are easy to learn and understand. Even if you do not see a use for them now, they will become more useful in more complex circuits. I hope this video has helped you understand the current divider rule and how it is used to calculate the current through the branches of a parallel circuit. If you find these videos helpful, please like the video, leave a comment, and subscribe to my channel. This is the only way I can continue to make these videos.